Hello friends, hope you're having a fantastic day today. Welcome to our system design series. Today is going to be an introductory lecture where we are going to be talking about what is system design, what is the expectation of an interviewer, and what type of questions can be asked in an interview. Then we will be busting some myths associated with system design. Now, without any delay, let's get started with the important stuff. Now, system design interview is something completely different compared to our technical interviews or lead code style interviews. In the technical interviews, we are typically given a set of problem. We are told that what are the parameters, and then there is only going to be either one or two optimal solutions that you need to reach at, and then you need to code out that solution. That's it. That's pretty much it. So the answer to your problem is actually a quantifiable measure, and more or less there is always going to be one or two answers that interviewer would know and would be judging you based off. System design interview is something completely different. It's a 180 from the technical interviews. This is totally a vast sea of information, and you can build your solution in any different ways. Like there, if I'm an interviewer and I'm interviewing someone, I'm absolutely certain about one thing, that the solution I have in my mind is never going to be the exactly same what the interviewer is going to be suggesting in their interviews. There are always going to be nuances, differences, some patterns and some modules and some commonalities would be there, but it's always going to be different. And as an interviewer, you need to be mindful about these things. You need to basically drive the conversation into a manner where you are understanding or asking clarifying questions, understanding the requirements, and requirements are never going to be just the core functional requirements. You also need to be very much concerned about non-functional requirements as well. You need to come up with the answers of these questions. So there is no one solution for any problem in a system design interview. Then how does a system design interview progress? That is the logical question that comes to your mind. And the way typically it moves forward is you need to be communicating all the ideas, asking clarifying questions, and talking about the trade-offs. Trade-offs is a really key measure of technical interview, because you need to understand that the way you are designing a system, what is going to be the reasoning behind it. It's not important that what technology you use, but you need to know the why, that why you are using that technology or why you are using this method, rather than talking about all the different things like what is going to be the load balancers and geolocations and AWS and Azure and things like that. They are not so important. More important thing is how you communicate, how you reason, and how you provide your trade-offs. These three things make or break any single system design interview, and this is what we are going to be talking about throughout this course. Now let's try to understand that what type of questions can be asked in a system design interview. Usually within the span of 45 to 60 minutes, you are expected to basically design a fully scalable, fully reliable, functioning system, and how it can be implemented in real world with real users and real use cases. And you need to design the whole idea behind everything, and plus trade-offs, as we already talked about. Now there can be four categories of these type of questions. Number one, you can be asked to design a product or a feature. If it's a very large product, you can be asked to design something like design YouTube or design Uber or design Netflix. Or you could be asked that, hey, we have this feature in Netflix that currently, let's say that we only support streaming. What if we have to enhance it to basically add live streaming on top of existing streaming? How would you design Netflix in that regard, and how you would change the existing architecture? How would you improve upon the new requirements for this new feature or this whole new product? These are very complicated problems because they basically contain a very large scope in mind, and you have to remember and think about a lot of different scenarios. Things like who are going to be the users, who would be impacted, what kind of events are we talking about, what kind of load are we talking about, how would that comprehend in terms of load, in terms of money that we would spend on the compute, security aspects, and all the different things. Because these are very broad category of questions, and the discussion can go diverge into any deeper understanding or areas, that whether the interviewer wants to take it or whether the interviewee has some expectation on. So these are very complicated in my opinion, and I see more instances of questions like these being asked at senior or very senior level positions. Next, it can be something like design a component or design a service. Now, what do we define by design a component or a service? These are systems that basically complement the existing features or set of functionality. Let's say that we already have a product in mind, we already have Google or Amazon or AWS, and we are being asked that, hey, you need to design a rate limiter system for our amazon.com website, or you need to design a notification service that is going to work behind the scenes for our, let's say, Instacart or Shopify or some website like that. How would you design that? So in this regard, we already established that there is an existing set of functionality that is already present, and you are basically building a complementing service that most likely is going to sit somewhere behind the scenes and then supporting the users. So in that case, your user base would shift. Previously, remember, if you are designing Netflix, you are basically serving someone sitting on their drawing room and they are just trying to watch a streaming movie, Stranger Things or something like that. If you are designing a notification service, basically your client is going to be that, let's say someone made a purchase on amazon.com, and now one of the service in amazon.com wants to notify the client that, hey, your delivery is on the way. How would you define that piece? So now this is, you are designing a piece within a puzzle. In the first category, you are designing the whole puzzle. So now basically the scope becomes more specialized, the communication becomes slightly easier because your scope has reduced, but more or less the core specialized component that we have to talk about really shines in these type of questions. Because if I want to know that what is the person's capability in terms of their backend understanding or the database that they can support or the knowledge that they have, they become kind of fuzzy when we try to discuss the whole thing. Like if we have to design whole Google, we might not have more time to go in depth about like API design or database design or truly those kind of questions. But building a limited component size service, we can actually dive deeper into those type of questions as well. And don't worry if this feels overwhelming, because this is just an introduction. We will understand substantially about each of these components, and we are going to be seeing many examples throughout this course. Next, the type of questions can be design infrastructure component. So what do I mean by infrastructure component? Let's say that we already have like the whole service in place, but we want to improvise on certain areas, certain aspect. Maybe we don't have like we have 50 services, but we don't have a centralized logging service. How would you design that? How would you design that the whole user journey, let's say it goes through five of your different microservices or monoliths. It's currently, they all have the information of things they did during those modules, but you want to have like a centralized view of every single thing that the user done through all of that. How would you capture all of that? How can you design like a centralized logging system? That's a very interesting problem, because more and more companies basically try to solve these kind of problems in real use cases. It can be helpful for, let's say, guest services. If basically someone calls them then and says that, hey, I basically log in, I logged out, then I logged in again, then I revoke my password, then I purchased this item, return this item, then I purchased it again, and then there are like 10 steps I did. And the person on the phone, maybe if that person has to check for four systems before supporting the customer, that's a very bad experience. What if you can consolidate everything in the same place? And that is the component I ask you to design. That can be a valid question in architecture problem, where basically you're defining component of an infrastructure, or you're building like a monitoring pipeline. Those questions are pretty valid. Again, they become more specialized, but the communication becomes more interesting. And the last type of problem that I can think of, or the type of questions, is basically like a broader generic category, that is everything else, but basically we can tell them that truly architecture related problems. So let's say that you have an existing system and you want to make it now, you want to expand into multiple region. Let's say that because currently I'm working for a movie theater company, and we have a very solid functioning system that is basically completely based in Canada. But tomorrow our company acquires something in Europe or Asia, and now we want to expand in multiple regions. How would our system would comply, and what are the things we will have to do? So then it becomes a separate discussion where we are talking about a higher level of scale and how you can maintain the data integrity between different parties and how you can control some things, and how would you make some things global and some things regional, and what kind of algorithms you are going to choose and what kind of caches you are going to have, and things like that. Or like global geo replication, so things like that. We all seen AWS, Azure, they all go down from time to time, and if your system is fully reliant on just one place, one location, you are prone to error. So how can you improve upon your disaster recovery scenarios? So these are all going to be the fourth type of category of questions that can be asked in a system design interview. Now let's try to do a quick myth busting sessions associated with system design interviews. Most of the people have many misconceptions associated with system design interviews, so let me just clarify all of them for you for now. Number one and most common myth, that I must know every single technology. This is absolutely not true. What you should know instead is that you should understand when and why each technology is being used, and given your problem or your circumstances, which technology you should opt in for. You should not worry about before your interview that what if my interviewer starts asking me questions related to Cassandra DB or MongoDB or Redis Cache or Memcache or any other hundreds of different tools out there. They don't care about these things. While they do care about is that given the problem you have, what is the most optimal solution and the trade-offs you can think of. If you want to do fast retrieval of data, if why are you going to use cache, where you are going to put the cache, will it be on the client side, will it be on the server side, how it is going to be consumed, what is going to be the caching algorithm. These are the problems that interviewer is more concerned about, not that whether you know how does Redis cache work or what is the inner workings of memcache or something like that. They are more focused towards your understanding about trade-offs, and system design interviews are more about building reasoning towards solving problem. It's not a medium where you need to showcase your memorization skills of vast array of tools that you know, because if we just put Microsoft Azure, it has over 600 services that does different things, and some are common and some are vastly different. But now you can imagine that that is just one cloud platform I'm talking about. Then we have AWS, then we have GCP, then we have PCF, and hundreds of others different tech stack and technological solutions available. You cannot keep up with each and every one of them. What you should know is that underlying the given problem, what would be the solution? Is it going to be a compute heavy solution? Is it going to be an event driven solution? Is it going to be a backend data fetching solution? Or how you are going to be building your design? So you should be focusing towards that. Next common myth is that there is only one correct design and one correct answer towards your given problem. While I talked about it briefly, but I'm going to go deeper into this topic. This is absolutely false. For any single problem, there are many different ways to implement and solve that exact same problem. And interviewer has a very common expectation that whatever his or her solution is, it's now never going to be the exact same solution that the interviewee is going to present. We need different people for differing of opinions and understanding that what is the reasoning between selecting this tool versus that tool, or this technology versus that technology. And there are going to be a lot of different considerations. Again, it all boils down towards the trade-offs, the requirements, and what are the constraints you are bound within your given solution. They are more concerned about the questions that can happen in real life, things like what if my application is data heavy, how can I make sure to have strong consistency versus high availability? What are the different trade-offs? Can I get lower latency versus lower cost? Can I get simplicity versus flexibility? Can I get more disaster recovery versus cost association? These are the combination of questions you would be answering. So don't worry about that there is only one fixed solution. And personally, what I like to do always in my interviews is that whenever I'm presenting my solutions, and then let's say we went through the full 45 minutes of system design interview, and then in the last 5 minutes the interviewer would ask me that, hey, what was your opinion, or do you have any questions for me? I would always ask them that, hey, if you had to design the exact same system, how would you design it? What are the things you would do differently? Why would you do this versus that? and that opens up interviewer in like substantial ways. I've seen many interviewers be like, yeah, I would have designed very similar towards what was your approach, or in some interviews they were like, I had something completely different in mind and I was thinking more about doing it this way versus your way and things like that. So there is always going to be that back and forth communications, but more or less there are no two designs that are always going to be equal. So don't worry about it, that whether your solution is going to be completely different than what the interviewer is expecting. Myth number 3 is that if I memorize all the different patterns, I would be able to pass the system design interview, or I can fool my way around within the framework of the given interview. It does not work like that, because even if you, let's say, saw 50 videos on YouTube or some other platform about different solutioning interviews, and then you try to memorize all the different permutations and combinations and test cases and try to present your solution that way, that is not going to work in the real world. Because in the real interview, if the interviewer just changes one single requirement from the given set of all the questions, then also your solution would be completely different, and you need to understand that. So that's why the focus should be what the question is, what the problem is. And that is also somewhat similarly what we are going to talk about in the next upcoming sections, where will talk about the 6 system design framework questions that we have associated. That framework is basically generic enough that you can follow, but it is not restrictive that you are always going to be stuck or you can find a common pattern. Because again, I told you that this is a vast sea of technological solutions, trade-offs, and different reasonings that we have to provide. So don't memorize patterns, just always focus on the framework and the problems that we currently have. And last and final myths that I always see is that only backend engineers need system design. While I am predominantly a backend engineer in my past, and now I'm currently working as a solutions architect, but that is not always the case. I see a lot of very brilliant front end engineers who also have to think about different system design aspects. How am I going to make backend API calls? Can I combine these calls? For can I implement the timeout? How can I implement like client side loading versus server side loading? What if I need to use cryptography or hashing towards the communication I'm doing with the end client? Do I need to do it on the back end, or do I need to do it on the front end? What are going to be the different logic I can implement while communicating with the third party from the front end side versus the back end side? So these are all the questions and considerations that also front end designer also needs to think about. Plus, it does not matter if you're front end designer or front end engineer or back end designer, more or less you are always going to be working and thinking in terms of solution designing to make it more robust, more secure, more available, and how can it become feasible in terms of cost, in terms of latency, in terms of consistency of data, in terms of fast retrieval. So there are so many different ways that we need to consider, and again, we it all boils down to the problem versus the trade-offs versus the capabilities. Now, thank you so much if you made up until this far in the video. I want to clarify a couple of things. Number one, I'm putting more emphasis towards my health and trying to lose some weight because I'm obese, and this is something just I need to do. So that takes time away from what I can spend towards making these videos that I love making. But during the holidays, I would be crunching a bunch of different videos and then trying to post them regularly. So hopefully that would help in your journey. Second thing, I want to thank each and every one of you who has supported on my initiative and who has patiently waited for this course. I will try to put my utmost attention and detail in this course because it's a topic that is very close to my heart. And I just want to say thank you from the bottom of my heart. Also, thank you for sticking around and listening to the word trade off like maybe 50 times. That is just what the game is. And we will try to improvise on the quality of our videos. And in the next video, I'm going to be talking about the 6-step framework that I always follow that has helped me tremendously in my system design interviews. I wanted to cover it in this video, but then this video would have been much longer and most of the people would have missed it. So I felt that it makes more sense to create that as a separate video, and hopefully more people can adapt and understand what that framework is. Now, if you made up until this point, thank you so much. Just comment the word kiwi so I would know that you saw this video because I'm wearing green. And yeah, till then, take care.